Hello everyone, my name is Renata and welcome to the third session of NoMagic's webinar series, Model-Based Systems Engineering, from Theory to Best Practices. Today's webinar will cover Systems of Systems Engineering using DoDAF. The presenter is going to describe how to adapt modeling for building high-value models in an organization. The webinar consists of two parts, a brief theoretical base and a practical demonstration which covers modeling DoDAF viewpoints and models, analyzing model using coverage analysis, impact analysis, model metrics, and also we will share best practices from our clients. The session will be hosted by Lina, who is certified in different modeling areas like UML, SysML, BPMN, and her major expertise areas are model-based enterprise architecture solutions and business process modeling techniques. If you have any questions during this presentation, please ask them in the chat window. Questions will be answered later and published with a link to a video of the recorded webinar. The presentation will take approximately 45 minutes. So, Lina, are you ready to start?
Hello, everybody. Thank you, Renata, for introduction. So we can start with our first topic today, and it is managing complexity when modeling systems of systems using DoDAF. I will talk a little bit about the theory, and later you will see everything in our live demo. Most of you already know SysML, enterprise architecture. So today I want to talk how to manage all the information that we are collecting during the modeling process. From a SysML perspective, we are working with systems, paying more attention to the internal structure, behavior, requirements, or parametrics. The issue appears when we want to analyze related systems, see their connections, communications, when we want to see them in the context of the whole organization. So here we can use the enterprise architecture. It can be used to model a whole enterprise, single organization, department, program, or project. So the scope depends usually on the vision and goals of the organization. Usually if the company starts modeling, they have a pilot project to check if everything is okay. If the process works fine, they keep working in the same style with other projects. In such case, they expect to reuse some parts from the existing projects, do not start from the zero. If the company models the whole enterprise architecture for itself, it has to have the updated information all the time. If we want to collect and analyze information, we have to understand what the intersection between enterprise architecture and system engineering exists. Here we have main abstraction levels using enterprise architecture framework DoDAF. All architecture frameworks, like viewpoints, sit together. They start from defining concept and its capabilities in the capability viewpoint. Then we define from one to many operational scenarios here. So here we can define how we expect our system to work and how it interacts with the environment. And finally, we provide multiple designs or solutions for each operational scenario here. And then we perform trade-offs to pick off the best alternative. Sometimes it is difficult to separate the information, for example, which level should be chosen for the particular information, also how different abstraction levels should be connected. So we will analyze such situations during our live demo. Once we have SysML, it changes the capability configuration here. Sometimes once we have different departments, teams, contractors, and subcontractors, different abstraction levels allows us to separate responsibilities. For example, if we have a team which is working with systems engineering, and they can get the operational scenario as a project, which cannot be modified and can be considered, for example, as requirements for their systems. So they can analyze the requirements and prepare the specification of the system. We may have two ways of integration with SysML. We can use SysML compliance mode and model elements that have DoDAF and SysML properties. This scenario allows to trace in the context of all enterprise, to trace the systems, from the capabilities to the internal parts of the systems. In such case, You get the functionality from UPDM and from SysML as well. For example, you may create UPDM diagrams, or you may use SysML ones. Also, you will have the additional information, the additional functionality that comes with SysML. For example, integrations with other tools, simulation, and similar ones. The compliance mode ensures that the working process will be smooth and consistent. The another way is, instead of modeling DoDAF concepts, we can model SysML elements and diagrams. For example, SysML is stored as a separate project. It means that we already have capabilities, requirements, goals, organization structure, or main system view. And now we want to model each system separately. So every system may have its own SysML project. But the main point is to trace that all the blocks in the SysML are connected with SysML or systems with or capability configurations in UPDM, as you see here in the example. In such case, we use standard SysML relationships such as allocate, satisfied, or trace. Dividing model into the projects allows to manage the complexity, but still ensures the traceability. After separation into the several projects, do not forget to analyze model dependencies, because it will help you to have healthy structure of your projects. Once we have complex model, which contains enterprise architecture, systems models, we need to ensure that model is correct, that it satisfies the requirements, that it will work in the real life. So how can we do that? First of all, if we want to analyze the model, we should understand how information is grouped in the viewpoints in the model. Also, we should have a modeling process. Here we have an example how the process should look like. You may find it using our templates, and today I will create a model using the simplified modeling process during our demo. Here, we start with capabilities in the capability viewpoint, continues with operational viewpoint, then services and systems, and also we can add standards and projects. The process usually depends on the organization. Once we know the structure, we can start working with analysis. So the first step is coverage analysis. It allows to track how lower levels of abstraction covers or implements the higher ones. For example, how performance performs capabilities, how blocks satisfies requirements. In such cases, we can use relation maps, tables, matrices, or even count metrics. Once we have traceability from one level to another, for example, from capabilities to operational viewpoint, we can track the coverage. Here we have an example how model was improved, creating new performers. As you can see, I had the increased number of performers. They are covering the capabilities. And now I can track and understand if all my capabilities are covered, and also maybe I have too many performers and some of them should be reviewed and deleted. Metrics can be customized. It can be used everywhere in the model. And of course, for counting metrics, we can use all the information that exists in the model. So we may track various aspects of our project. The next step is to use the impact analysis. It's important and useful once we want to make changes in our project. For example, if I want to change the part of the block or the resource role of the system, so I need to understand what the impact to my system it will have. So predefined relation maps allow to track the different aspects such as context, inputs, outputs, other related information from different abstraction levels. So usually, directly related information we can find in the specification of the element, for example, right? But a detailed impact analysis allows to track the indirect dependencies and to ensure that all necessary information is collected and modeled in the project. The background for this analysis is the traceability. And traceability can be direct or indirect. as we already talked, and it can be represented in the specification dialog of the element, in the matrices, relation maps. New traceability rules can be created in the project and used for various purposes. So you can reuse the existing traceability rules, you may create the new ones. And what is important, that even we have different standards in the same project, for example, UPDM, SysML, or UML, we can have traceability rules to track the elements in the one project or even in the group of the projects. Last, but not the least important, is modal execution. And of course, parametrics. Here we can analyze parameters of elements that can be countable. Also, we can simulate the model to understand how our system will work in the real life. Once we have enterprise architecture SysML, we can simulate all views, like DoDAF views, and also like SysML diagrams. And of course, prepare the conclusions about the status of the project. So, we talked about the theory, and now we should see how and what we can do in our practical side with our tool. I will use our product, Cameo Enterprise Architecture. So you can do the same if you have Magic Draw with SysML and UPDM plugins. So let's start with our tool. Here we have our Cameo Enterprise Architecture tool. Some of you already work with our product, and some of you maybe will find new features here. And I want you to remember the old truth that we need for modeling tool, language, and a method. So here we have a tool, two languages, UPDM and SysML, and freedom to choose the method. Every organization can decide which method is best for them. Method usually defines process and all necessary elements. And today I will have a short scenario of the method, which you can adapt in your organization as well. At the same time, I will show how to identify different levels of information abstractions, how to separate them, how to connect, or how to analyze. I will model according to our DoDAF sample that you may find in the tool. I will call it SAR. It will be a search and rescue project for saving people in land or even in the sea. So later you may see how it looks like in our tool. And now I just will use the main elements that are necessary for my scenario. The first part will be for modeling, and the second part will be for analyzing. But I believe that I will mix them to show the consistent process of modeling. So today I'm creating a prototype of search and rescue project. Since we already talked, the first step and the first viewpoint is capability viewpoint. Here I need to identify the capabilities of my organization. It can be a project as well or the enterprise. And I want to create 4 capabilities that are the main ones in my project. And here I will use a new functionality. First of all, I'm creating the new diagram, CD2. Yes, and now from the Word, I will copy a simple list and I will paste it in the model. I'm choosing capabilities, and here I can see all my capabilities right here, and I do not have to type them by myself. Now I just have to connect them. I will connect them using aggregation relationship. Actually here composition. I want to see that my main capability consists of 3 capabilities like search, recovery, and assistant. And I'm not planning to model other elements because I believe that for me it's enough to understand what my organization is doing in the highest level. Sometimes we can call them capabilities, we can call them high-level requirements, main use cases, sometimes strategy. It depends on the terms that you are using in your organization. Today I will call them capabilities. This is the first abstraction level, the highest one, to identify what my organization is planning to do. The next step of abstraction is going into the details and defining operations and operational scenarios. For example, I know that I will need 3 performers. For them, I'm creating OV2 diagram. And once again, I will create using paste method my performers. And I want to say that my performer, person in distress, is sending a distress signal to my search node. I do not have such information, so I will have to create it right here. I will use operational exchanges. And right here I can create all the necessary information as well. I can do that in containment tree. I'm choosing where and I'm choosing what. So now I will create a distress signal. And I know that my search node will analyze the information and send medical conditions and location to the rescue node. So first of all, I'm creating medical conditions. And I decided that I need one more thing, location. I'm doing in the same way. If I have information and I can copy paste them again to the model very simply. So here is location. Yeah. So now I see all the information that is important for me here, but it's not enough. I want to mention a couple of things. That this is just structure and sharing the information. I want to see how it is performed in a sequence, in a time. So for that I want to use operational activity diagram or the 5B. And here I can simply reuse my performers very simply. I can drag them to the diagram and create swim lanes. I want to say that I will start my process, and I know that my person in distress is sending a signal. I know that search node receives a signal. It can be a distress signal as well. I know that it creates new information and sends medical conditions. And location to rescue node. And rescue node will receive information, for example. So here we have a very short scenario, and that's enough for me at this time. I want to finish my flow. So what is the most important thing that I want you to show here? We modeled the communication here, and we want to show the same communication and exchanges of information in my activity diagram. So I do not have to start from zero. I can reuse the same information. If I know that my person in distress is sending a signal, I can use the same information here. Person is sending information to such node. So here I can find the information that using Operational Exchange Manager, I can realize that operational exchange. I can do that the same here. I have two. I have location and medical conditions. So here I do not have, I can simply create. The creation is, shorter way is to select the element, drag on the relationship and say, okay. So this is my scenario and I have almost everything in the operational viewpoint. What I wanted to show that once I create the information here, the operational activity actions, operational activities are connected with my performance. I can see that, for example, using dependency matrix. It's very simple. You may drag operational activity, you may drag performer, select the criteria, the relationship for them is capable of performing, and here I can see the matrix with the information that my performers are connected with my operational activities. But that's not all. Once I have information in the operational viewpoint, I should connect these two different abstraction levels that I already have. That means I have to connect capability viewpoint and operational viewpoint. So I can do that in two ways. I can connect performers with capabilities and I can connect operational activities with capabilities. So in the first way, I will show you how I can do that in CV2 diagram. I'm choosing my performers and simply connect them with my capability. Here I can use my layout and see a better view. For operational activities, I will use dependency matrix again. I just want to change the name of my main operational activity. Let it be search activity. And now I'm creating a new matrix. Let me find it here. I'm doing the same. I'm dragging here operational activity. Here I'm choosing capability and selecting activity part of capability right here. And here I have the information, and I wanted to say that my search activity is implementing my search capability. That's all. Already I have my connections. So once the relations between different abstraction levels exist, I could track are all my capabilities covered, or maybe we have too many performers, or maybe too many operational activities. So here I can use my predefined relation maps and to analyze the relationships between different abstraction levels. So I can create two different predefined relation maps. One is structural. So here I can see my main capability and its internal capabilities. And here I can see that this search capability is implemented by 3 performers in my operational viewpoint. I can do the same with the structure operational elements, creating capability behavioral map. Here I have more information. I have the main capability is internal structure in capability viewpoint, and I know that capability search is implemented by search activity, operational activity, and it consists of 4 additional operational activities. So once we have the view of the structure, I can analyze it using metrics. It means that I can count what is the coverage. For that, I can choose the package of my capabilities and use tools and metrics and create a new metric table. Here I can see the list of my metrics that can be counted for my capabilities. And now I'm choosing the just performers nodes, and new metric table is created. and all the information is counted. As you can see, here is a date, number of capabilities, number of nodes. I know that only one capability is covered, and percentage is 25. Using the same map, I can create, for example, one more additional element. For example, I'm creating performer for my recovery capability, and let's name it station. And now I can recalculate my information, like new data, and I can see that I have 4 nodes performers, and now the coverage is 50%. So we created almost everything that is necessary in the OD viewpoint and in the capability viewpoint as well. So the next step is to go into more details and create a couple of solutions, tactics for my operational scenario. So I can do that again with my structural relation map, this one. I can choose my performer, and I want to create 2 capability configurations for it. One will be named search unit version 1. I'm using Ctrl Enter, and the second one is search unit version 2. I will explain why do I need two elements here. And these 2 scenarios can be used for 2 different reasons. The first one, that I can choose the best one, which is the better, unit version 1 or version 2. So I can use parametric diagram for calculations, measurements, metrics, it depends. I can also simulate. But the second scenario is that I can treat the first version that it will be used for 1 period of time, and I can say that version 2 will be used for the next period of time. So it means that I will prove version 2, and it can be used as a better one. In such way, I will show you how to model that in the SV8 diagram. But now I want, first of all, to model the internal structure of my capability configurations. For that, I will add 5 systems into my project. But now I want to turn on SysML compliance mode, and to show you that I can do all the same actions. Then my elements have SysML and UPDM properties. So SysML compliance mode is turned on. They're asking me, do I want to add such properties to the existing elements? So I'm choosing to have only to my new ones to the systems. And now I'm again copying information from my list. I'm going to SV2 diagram, and I'm creating, I'm pasting the elements, and I'm creating systems. Here we have 5 system elements, and I can check that, for example, now I can have not only UPDM diagrams, but also SysML diagrams as well. So it means that I will have functionality from SysML and UPDM as well. So the next step, I'm creating internal diagram for my search unit version 1. It will have yacht, which is in distress. It will send a distress beacon to the complex SARSTAT system, and it will give the information to my search pod. I will use resource ports, and I will show you how to do that in the fast way. Here I have a signal. This similar signal will be sent from system to search bot, and it will also send, for example, coordinates. If I do not have information that I want to send, or the type of information, I can simply create it here directly in the container tree. So first of all, I will create a signal, and then I want to create, for example, coordinates. So now I can drag signal on ports, and the type is set. So I do not have open the specification. And here I will have coordinates. Now I will connect them using connector, and I will want to say that they are sharing information, these ports. And I will use that fast way for creating resource interactions. I simply drag it on the connector. That's all what I need. And here I can drag as well. And here will be coordinates. That's all. So I have the internal structure. That's enough for me to understand. But once I have, sorry, I don't want it. Once I have the internal structure, it is like you have a SysML model of the system or a PDM model, doesn't matter. But sometimes we want to see the higher level of our systems, how they are communicating. So in such way, I can reuse all this information, all this communication, and I can create a SV2 diagram, add my main elements like yacht, compass as a system, and my search boat, and to show the communication, and to show it here. I will add the additional information that it is resource association, PDM. And now I can reuse the existing information, like it was sent between resource roles, but I can use it here. And I can do the same with signal and coordinates. I do not have to create that information from zero. So the next step that I want to show you is adding my search helicopter, a new system. As you remember, I created 2 versions of my search unit, and I want to say that later my search boat will be changed by search helicopter in the version 2. But here I want to show that my helicopter is inherited from search boat. It means that it will have all information that search boat has and some additional features. Okay. But what is happening when I want to model the internal structure of my search unit version 2? Let's see. I'm creating the internal diagram, and I'm using the same scenario. I will have yacht with distress beacon, and the resource role is new because the context is different, but from the type I'm collecting my resource ports, and I do not have to create them. I can just simply reuse them. So once again, I'm adding compass. It also have all necessary ports that I need. And now I'm adding search helicopter. And even this element also collects the information from its parent, let's say, all the inherited information. So I can simply connect once again my resource ports. And what is important, this is resource ports and SysML ports as well. Important that I do not have to create that information from zero. I can simply reuse it if that information is useful for me. Of course, I can change the signal to the new one if it is improved in the newer version. But for me, it's okay. I'm reusing the same information that I already have, but just wanted to say that that information is exchanged between compass SARSAT system and search helicopter. So all the information is added and reused. What is the next step? The next step is what I want to emphasize, and I already mentioned in the theory, that here I can check and analyze the impact. For example, what will happen if I decide to change my search port, right? What kind of effects I will have in my project? So I can choose the element and I can analyze. I can use resource impact analysis or resource role impact analysis. So right now I will create resource impact analysis, and here I have various criteria like resource interactions, internal elements, and of course relationships with other elements like inputs, outputs. I also can define the elements from the other abstraction levels. So such relation map, we have 4 predefined relation maps. They allowed me to better understanding what is the structure of my elements, how they are connected, and of course how they are connected using indirect relationships. So once I have the internal structure, once I have my capability configurations, I have to understand how it will be implemented, comparing and analyzing the capabilities. So here I can use CZ3 diagram. It is a special one diagram, which is capability phasing. And it means that I want to say that I'm using my search capability. I want to say that during one period, search unit version 1 will implement my search capability. So I'm adding new capability provision. I'm choosing search unit 1, and it will, let's say it will work for in the May. Let it be like this. Okay, I can like this. And for the next period, I want to use my search unit 2. So here, for example, it will work in June. Let it be. Right. And I know that during this period, my search capability will be implemented by search unit version 1. And during this period, it will be implemented by the version 2. If I don't want to see capabilities, I can use SC8 diagram. And I can simply add versions like version 1 and assign the resource, assign my version 1. And here I can add one more, version 2, and assign the another resource. So what do I have? I have the same view, but we're talking only about the versions of my capability configurations. Okay, now I have relationships between 3 abstraction levels, between capability and operational, operational and systems, and even systems and capabilities. But one more thing I want to add to our project is project management. It means that once I have capabilities, once I have systems configurations, I want to model when and how these capability configurations should be developed and implemented in the system. For such reason, I can define and manage projects. I'm creating 2 projects in my project viewpoint. Project 1 will be, let's call it project search unit version 1, and the another project, let it be project search unit version 2. To show them, it's better to create a Granchart diagram, and I can do to my projects, but they do not have any dates. I can define them in the specification, or I can simply define them here. Let it be May, according to my capability configurations, and here let it be June, Okay, I have the timelines, but they are not connected with my capability configurations. So right now I want to connect them. I can do in one way I will show you right now. Here, as you remember, I have the start and the end dates. I can reuse them for my projects. I'm creating for here diagram PD1. I'm adding my projects here, right? And now I have my milestones. They're connected with my capability configurations here, 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 and here. So I can add them simply to my project by dragging. Of course, I can do that in the specification as well. This is my main. I'm adding to my main. And here I can see that these milestones are added to my project. And I can do the same with my another project. So what do I have now in my Granchart? I can see these milestones on the project. And here you can track the status. You may define the project threads. Here we have the predefined ones. For example, you can see them here, and every stage has status indicator. For example, if I have a leadership, I can see that it's in analysis. If it is a personal, it can be in development, for example, right now, and facilities in development. And once I finish, all the information I can see in my Gantt chart. So now we managed to collect quite a lot of information, adding projects, and it can combine operational and systems and capability viewpoint. And the last thing that I wanted to show is that we created a lot of information. What have changed in our relation maps? So we can come back to our two main relation maps. The first one was behavioral and structural. So as you can see here, I have already 3 different abstraction levels. I have capabilities, I have operational, and now operational level is implemented by system level. Our behavioral map hasn't changed because I didn't model the functions in my system viewpoint. So I believe that's all that I wanted to show today. So I can come back to my presentation and summarize what we have talked today. Here, so we have here again, we have our DoDAF process, and I can track what we managed to analyze today. We managed to analyze our capability viewpoint and manage model capabilities. In the operational viewpoint, we created operational activities and performers. We connected them, and we also connected them with capabilities. The next step was identifying solutions, our capability configurations, and modeling the internal structure of them using as we do. Also, we analyzed them in the timeline, and we connected our systems with our performers in the operational viewpoint. And the last thing that we managed to do was creating projects for implementing systems and analyzing them according to the time and implementing our capabilities. So we managed to cover mostly everything in our DoDAF framework except standards and services. So I believe that's all from me today. Thank you for participating.
Thank you, Lena, for this informative presentation, and thank you everyone for participating. If there's anything we didn't cover today, please do not hesitate to contact us with your questions at any time. We appreciate your feedback. We consider it when improving our webinars. So thank you again, and we hope to meet you in the upcoming webinars.